Okay, this is my third time trying to record this because the first two times the audio did not capture. So let's try one last time. Okay, today we will be adding and subtracting radical expressions. So we have 3 radical 3 plus 2 radical 7, and these are what we call like radicals. So when the root, let me try to use a thin pen here. Zoom in just a tad. Okay, so we have a square root, right? So when the square root, the root is the same and the radicands are the same, we can combine these because they are like radicals. So we do 3 plus 2 is equal to 5 radical 7. Notice the radical 7 does not change. It's still a root 7, a square root, right? It's not, root 7 times root 7, none of that, right? Just like when we combined like terms for, these kinds of expressions, like 3x plus 4x is just 7x, right? There are 7 x's, so that's all this means. So we look at part B, we have 7 root 3 minus 4 root 3. That means these are like radicals, right? The square roots are the same. The numbers under the radical, the radicands, are both 3. So 7 minus 4 is equal to 3 radical 3. Moving on, we have 5 radical 10 minus 3 radical 10 plus 2 radical 10. So these are like radicals. So we have 5 minus 3 is 2. 2 plus 4 is 4 radical 10, right? Now in part D, this is our first example of not like radicals. You can see the roots are the same, right? They're both square roots. However, the radicands are different. One's a 5 and the other is the 3. So you cannot combine these. This is exactly like having 2x plus 3y. You can't combine them because they're not like terms. And likewise, in letter E, you can see this is a square root versus a cubed root, right? Even though the radicands may be the same, the roots are different. So these are not like radicals, right? So both of these, not like radicals. In letter F, we have 5 root x plus 2 root x. So they are both square roots of x. So we can do 5 plus 2 is equal to 7 root x. Right? And you can add more variables to this. For example, over here we have 5 radical 3ab, right? So it's a square root with 3ab as the radicand, square root of 3ab, square root of 3ab. So these are like radicals. We have 5 minus 2 is 3. 3 plus 3 is 6. So 6 radical 3ab. And in the last example, we have the cubed root of 3x squared. So the root, that index here, the 3 and the 3, they're the same. The radicand almost looks the same. However, we have an x squared here versus x to the first, right? Because they are different, it does not matter if the 3 is the same and the x is the same. The exponents are different. Therefore, the radicands are not the same. So these are not like radicals. Okay, let's move on to some practice problems here. So we have 5 root 3 plus 2 root 3. Now, the root 3's are the same, so we can add 5 plus 2 is equal to 7 root 3. Then we move on to B. We got root 5, root 5, root 5. These are like radicals. So I got 7 minus 2 is 5. 5 plus 3 is equal to 8 radical 5. In letter C, you have radical 3 and radical 2. These are not like radicals, so you cannot combine them. Not like radicals. So you just leave them as they are. Let's look at D. Radical 2y plus 5 radical 2y minus 3 radical 2y. So these are all the same. Now don't forget, this is a 1, right? We have 1 radical 2y. So 1 plus 5 is 6. 6 minus 3 is 3 radical 2y. Moving on, we got 2 cubed root of 3m, right? So this is cubed root of 3m. This is also cubed root of 3m. These are like, so we can do 2 minus 5. 2 minus 5 is negative 3. And we have the cubed root of 3m. And last but not least, this is a square root, right? Square root versus a cubed root, even though the radicands are the same, the roots are different, right? So we have different roots or indices. This is called an index, right? So these are not like radicals. Very good. Let us move on. Okay, on the left we have radicals now that we need to combine. However, you'll notice you'll need to simplify some of these first. So you notice we have radical 48 plus 2 root 3. They are not like, at least the way they look right now. So what we do is we first simplify radical 48. So radical 48 is radical 16 times 3, radical 3. So this is my 4 radical 3. Right? So now I have like terms here. So I can do, over here I have 4 radical 3 plus 2 radical 3. These are like radicals. So 4 plus 2 is 6 radical 3. Right? Let's move on to the next. I have in letter B, radical 50 minus radical 32 plus radical 98. So I know they showed the work here, but they didn't completely show how we simplify radical 50, right? So let's do that. Radical 50 is equal to radical 25 times radical 2. So that is 5 root 2. Let's do radical 32. So radical 32, I see there's a 16 times 2. So root 16 times root 2 is equal to 4 radical 2. And last but not least, radical 98. That one's a larger one, but I see a 49 in there. So radical 49 times radical 2 is equal to 7 radical 2. So now I replace each of these with its equal, simplified versions. So that is 5 radical 2 minus 4 radical 2 plus 7 radical 2. So these are all like radicals. We have 5 minus 4 is 1. 1 plus 7 is 8. So our answer is 8 radical 2. Okay, let's move down a little bit, make some space. All right, we have letter C, x radical 2x plus 3 radical 8x cubed. So there are two ways to do this. First, you can just simplify the, actually, there's not two ways. Let's simplify this first. So the first term is okay. The second term needs to be simplified. So I know that this is 3 times radical 4x squared, right, times radical 2. And that's my 2x right here. So this is 3 times 2x times root 2. And there's my 6x radical 2. Now once I get that, I can just substitute. I got x radical 2x plus 6x radical 2. Oh, I forgot the x here. This is x cubed. I should have wrote x cubed here. So there's an extra x that I did not write. Sorry about that. So this is an x, right? So these are now like radicals. So 1x plus 6x is equal to 7x radical 2x. And that's it. Let's do part D. So in part D, I see cubed roots. The cubed root of 2a minus cubed root of 16a plus the cubed root of 54a. Now, the cube root of 2a is okay, but the cube root of 16a and the 54a need to be simplified. So I see in the cubed root there's a, let me redraw that. There's an 8 times the cube root of 2a. Cube root of 8 is equal to 2. So this is 2 cubed root of 2a. And then the next one is cubed root of 54a. And I noticed that this is 27. There's a 27 in there. Cubed root of 27 times cubed root of 2a, right? 27 times 2 is 54, and that's my 3 right here. This is equal to 3 cubed root of 2a. So now I can rewrite all of this. The first term was cubed root of 2a minus the second term is 2 cubed root of 2a plus 3 cubed root of 2a. So these are all like radicals, right? Don't forget this is a 1. So 1 minus 2 is negative 1. Negative 1 plus 3 is equal to 2 cubed root of 2a. Okay, let's do some practice problems. Oh, I did not mean to do that. Okay, our first problem here, let's do A. So we have to simplify radical 125. So radical 125, I see that there's a 25 in there and a 5. Right? 25 times 5 is 125. This is equal to 5 radical 5. So now my problem is 5 radical 5 plus 3 radical 5. These are like radicals. So 5 plus 3 equals 8 radical 5. So there's my part A. Let's do part B. So in part B, I have radical 75 needs to be simplified. So that's radical 25 times radical 3. And that is 5 root 3. Radical 27, that's very similar. I see a 9 times 3. So radical 9, radical 3. So that is 3 radical 3. Next one is radical 48. So I see a 16 times 3. So radical 16 times radical 3. That is 4 radical 3. So again, simplifying radicals, it takes practice. Once you get, once you get good at it, you'll be much faster. I know some of you are just struggling with it, and you can also, break it down into factors and try to figure it out from there. All right, let's rewrite this. The problem is 5 radical 3 minus 3 radical 3 plus 4 radical 3. So these are all like radicals. 5 minus 3 is 2. 2 plus 4 is 6. Root 3 is our solution. Okay, let me scroll down here. Okay. So my next example is C. Oh, forgot to switch to pen. We got part C. I have 5 square root of 24y cubed that I need to simplify. So this is 5 times, and I see that, let's see, this is 4 times 6, right? So the y's I'm going to split up to, right? So that's 4y squared times radical 6y, right? So this is my perfect square. That gives me 5 times 2y times radical 6y, and these multiply outside of the radical, so that's 10y radical 6y, right? So be careful not to multiply, non-radicals under the radical. That's a common mistake. Okay, so the second one seems to be okay, y times root 6y. So the new problem, or the problem rewritten, It should be 10y radical 6y minus y radical 6y. So these are like radicals. 10y minus y is 9y radical 6y. Okay, so hope you're doing okay. Please rewatch the video if you're getting stuck. Okay, the last one is the cubed root. So remember, I asked you to memorize up to 5 cubed, right? So yeah, go over those. So the first term, I see cubed root of 81x. And I see there's, if you get stuck, right, you could break it down into factors, but it's a 27 basically times 3. But let's say you got stuck, right? You can do 9 times 9 is 81, and 3 times 3 equals 9, 3 times 3 equals the other 9. So now I see 3 of these 3's, right, because it's a cubed root. So I know this is basically a 27, or cubed root of 27, right, times 3x, like this. So if I split these up, right, actually, let me write these separately. So the cubed root of 27, right, times the cubed root of the other factor, which is still a 3, and the x. So that's how I get 3 cubed root of 3x. That's the 81x, right? The second term is okay. Let's work on the third term, cubed root of 24x. So I see an 8 in there, 8 times 3. So cubed root of 8 times the cubed root of 3x. And that's my 2 cubed root of 3x. All right? Now let's rewrite this. So the first term was 3 cubed root of 3x minus cubed root of 3x plus 2 cubed root of 3x. And these are all cubed root of 3x's. Those are like radicals. So this is 3 minus 1, right? That's 2. 2 plus 2 is 4 cubed root of 3x. And there you have it. Okay. I will cover one of these just so that you know how to do it. So we have these fractions under the radical that we learned yesterday, right? Let's take a look. So we have root 2 over 3, which we should separate, right? So we learned that root 2 over 3, using our quotient property of radicals, we can separate them, right? And because we don't want radicals in the denominator, we have to rationalize, right? So rationalize means you multiply this to get a smallest perfect square. So we have to multiply by root 3 over root 3, which is a value of 1. Therefore, the value of this entire number doesn't change, right? It just, the way it looks changes. Okay, so we have something equivalent. So root 2 times root 3, right? That's our product property. So we can multiply and get root 6 over root 3 times root 3 is just 3. So now our new problem is 2 root 6 plus root 6 over 3. So notice this is a fraction, right? I have to multiply by something. First, I have to identify the LCD. The LCD of 1 and 3, I hope, is pretty obvious. It's just 3. So the second fraction is okay, but the first term, I actually have to multiply by 3 over 3. Therefore, I get 6 radical 6 over 3, right? You can only multiply numbers outside of the radical, not with the numbers inside, right? So that's why it's 6 root 6 over 3 plus 1 root 6 over 3. So you see how these are the same denominators and these are the like radicals. So you can add 6 plus 1 is 7 root 6 over 3. And you just want to make sure the fraction outside the radical is simplified. It can't be reduced, so that's the final answer. Okay, so I'm going to do two more examples of that, and we'll move on. Okay, here we have root 5 over 3 plus 2 over root 5. So first I need to rationalize this denominator, right? So I multiply by root 5 over root 5. Therefore, the value does not change. This is equal to 1. So I have 2 to 5 over 5. So now I can replace the second term with this new fraction, equivalent fraction. So the problem is root 5 over 3 plus 2 root 5 over 5. Now the problem is they are different denominators. We need an LCD. The LCD of 3 and 5 is 15. Right? So I need to multiply the first fraction by 5 over 5, the second fraction by 3 over 3. So I get the result 5 radical 5 over 15 plus 2 times 3 is 6 radical 5 over 15. Now that the fractions have the same denominator, I can add the numerators. These are like radicals, right? So 5 plus 6 is 11 radical 5 over 15. Okay? Let's try the last example here. Okay, I have to rationalize this first term. So 3 over root 10 multiply by root 10 over root 10. So I get 3 radical 10 over 10. So this problem currently is 3 radical 10 over 10 minus radical 10 over 5. But you can't subtract yet, right? We need an LCD. What is the LCD of 5 and 10? It is 10. So the first fraction is okay. I just have to multiply the second one by 2 over 2. So now I have 3 radical 10 over 10 minus 2 radical 10 over 10. So now the like terms, right, with the same denominator, 3 minus 2 is 1 radical 10 over 10. Very good. Let's move on. We will be multiplying radical expressions. Oh, too close. Alrighty. So here we learned the other day, right? If the roots of both radicals, or all the radicals, are the same, right? If it's the nth root of a times the nth root of b, you can multiply them as the nth root of a times b. Right? You could add more than one or two terms. For example, if I give you like the cubed root of 2 times the cubed root of 3 times the cubed root of 5, right? They all have the same root. You can multiply them under the same radical. 2 times 3 times 5. So that's the cubed root of, what is that? 6 times 5 is 30. Right? So same idea here. Root 7 times root 5. They're both square roots. Therefore, you can write it as the square root of 7 times 5 is equal to the square root of 35. Right? Even if you add variables, it does not really change much. You just have to multiply the numbers, right? So you have root 3x times root 10y. So 3 times 10 is your 30, and then x times y. However, in part C, you're going to notice that, actually, no, this is not it, but you just cubed root, they're both cube roots, so 4 times 7 is 28, and then x times x is x squared. So these are not complicated yet, so let's try the problems on the bottom. So radical 6 times radical 7, they're the same square root. So this is just the square root of 42, right? Okay, let's move on. Radical 5a times radical 11b, right? So radical 5a times 11b. So this is radical 55ab. And the last one, we have the cubed root of 3y times 5y is equal to the cube root of 15y squared. Nothing we can simplify there. Okay, let's practice examples where we have to actually simplify them. Okay, so in the first example, we have radical 3 times radical 6 is equal to radical 18. 3 times 6 is 18. Radical 18 needs to be simplified by doing radical 9 times radical 2. And there you have your 3 root 2. Now I want to show you a second way of doing this. You do have to know this first way, but the second way sometimes is it makes your life a little easier. So look at this. Radical 3 times radical 6. So I know 6 is basically radical 3 times radical 2, right? So I have radical 3 times my radical 6 here, and I see that these are the same. So this is 3 radical 2. Okay, so as we practice more of these, you can multiply, like the next example, right? The 5x and the 15x give you 75x squared, and then work backwards to figure it out, right? But let me show you the second way, right? We have radical 5x times radical 15x, right? I see that 15x has a radical 5x and a radical 3. I chose 5x because I see a 5x over here, right? So that's a little shortcut. This becomes 5x, and you still have your radical 3. So practice both ways. I think knowing both is absolutely helpful. Let's look at the cube root. So this problem, it might be easier to actually just combine it. So I would actually just multiply it first to see if it indeed is easier. Sometimes it is, sometimes not necessarily. But if you did combine, it's 40, right? A to the fourth, b to the third, as you can see right there, right? And it's a cube root, so we're looking for 8 times 5. So we separate it into cube root of 8a cubed, b cubed, and the cube root of 5a. So this simplifies to 2ab times the cube root of 5a. So this one was pretty easy to do it that way. And if you did want to try it the other way, it's very similar. In essence, it's the same thing. But I just don't multiply the numbers. So I know 4 is 2 times 2. And 10 is 2 times 5. So that's how I can see there's a 2, 2, 2. 3 2's here. Right? So that's how I know this is an 8, right? And then I look at the a's. A to the third, b to the third, times your other factor is 5 and 1a left over. Cube root of 5a. Okay, so just from that, without multiplying, I can figure out what these roots come out to. Next, I know this simplifies to 2ab times the cube root of 5a. Okay, let's practice some of these down here. So this is a perfect example of what I was just sharing. Root 10 times root 20. So root 10 times root 20. So I want to look at the different radicals that are there, and I see in root 20 there is there's a root 10, right? There is a root 10 times root 2. So this makes it a little easier for me to visualize, right? So this is 10 radical 2, right? The book way, or the original way, is to multiply, right? The other way was to do radical 10 times radical 20 is equal to radical 200. And then you would have to separate this to radical 100 times radical 2 is equal to 10 radical 2. Either way is pretty easy, but sometimes this is easier. So let me try the second one. We have root 6x times root 15x. And in the 6, I have 2 times 3. In the 15, I have 3 times 5. Right? So I see 2 3's. So I know this is the square root of 3 times 3 is 9x squared times the square root of the remaining factors, which are 2 and 5. So that's 2 times 5 is 10. Does that make sense, I hope? right? So this becomes 3x radical 10, right? The other way is just to multiply 6 by 15 and we get 90, right? Which is not that difficult either, right? You could have just done 6x times radical 15x is equal to radical 90x squared. Therefore, you get radical 9x squared times radical 10, which is the same result, right? This is 3x radical 10. So either way you do it, it's fine. Part C, cubed root. So again, cubed root we can multiply and get the cubed root of 9 times 6 is 54, p to the third, q to the fourth, right? And when you see that there's a 9 times 6 here, this is the cube root of 9 p to the third, q to the third times cube root of 6q, right? 9 times 6. Oh, no, that's incorrect. Why did I do that? This is cube root, so I should be doing 27, not 9. So let me erase that and start over. This is the cubed root of 27 p cubed, q cubed times 2q, which are the remaining factors. Now we get 3pq times the cubed root of 2q. So that's the original way of doing it. If you want to do the other way, you could also do or 9p squared q squared times cubed root of 6pq squared. So I know 9 is 3 times 3, 6 is 3 times 2. So that's how I see 3 is 27. So the cubed root of 27p cubed q cubed times the remaining factor is 2q. So this just helps me organize my numbers. So I can basically end up with the same result over here. I just don't multiply it, so I get the 54. So you see how it's the same thing. 3pq cubed root of 2q. Same answer. Okay, the last thing we will cover today is multiplying by distribution. So we have distributive property, right? We have radical 2 times radical 5, radical 2 times radical 7. So radical 2 and 5 give you radical 10 plus 2 and 7 is 14. So these are not like radicals, so we leave it at that. But the second problem, I see that we have some simplifying we need to do. So the book way is to do radical 3 times 6 is 18, right? And radical 18 plus 2 radical 3 times 15, that's my 45. So we have to simplify these radicals. So this is radical 9 times radical 2 is 3 root 2. And this one is 2 times radical 9 times radical 5, right? So that gives me 2 times 3 radical 5, which is what? 6 radical 5. So 6 radical 5. And there's a plus sign in between. These are not like, so we leave it at that. Okay, in the last problem, we have radical x times radical 2x. So we end up with radical 2x squared plus radical 8x squared, right? The radical 2x, this becomes x radical 2. But the radical 8x, what is that? That is root 4x squared times root 2. And here is my 2x root 2. So I have x root 2 plus 2x root 2. These are like radicals. So x plus 2x is 3x root 2. Okay, so that one was a little more complicated. So just be careful when you simplify radicals. Let's look at the last three problems. We have root 3 times root 10, that's just root 30, plus root 3 times root 2, that's just root 6. And these are not like, radical 30 does not simplify, right? Even though it looks like a 6 might exist there, but it's just 6 times 5. You can't simplify that. So don't get confused by that. All right, next one. You see how it's radical 2 times a non-radical? So that's just 3 root 2 plus 2, and then the radicals. 2 and 6 give you 12. So we have to simplify this. This is 2 times root 4 times root 3. That is 2 times 2 root 3, right? And that is 4 root 3. So I have 3 root 2 plus 4 root 3. These are not like, so that is it. Last one here, we have radical 3a squared plus radical 12a squared. So the first one is just a root 3. And the second one, I see this is plus radical 4a squared times radical 3. And this simplifies to 2a root 3. So a radical 3 plus 2a radical 3 gives me 3a radical 3. Okay.